Hello friends, Dr. Anuradha from KKR Institute of Engineering Education and Research, Nasik welcomes you in e-classroom of subject engineering physics. Today the point of discussion is physics of nanoparticles. In physics of nanoparticles, we have to start some back history with the scientist Richard Feynman. In 1950s, he started with the concept of a saying that why not mimic the nature. What is the nature? What nature that natural observation was with him? That nature was trying to make things smaller and smaller. So why not the technology should become smaller and smaller? Functionally it should be the larger, but size wise it should be the compact. And in this way, his team has started moving in a direction that to make technology smaller and smaller. And nowadays, we are observing the fruits of that smaller technology. That time, the computers were of the room size computer now has been reduced in a compact size, and palm size computers are with us. So such a technology further called as nanotechnology. Nano means very small, a dwarf of particles having a size in the range of 1 nanometer to 100 nanometer, and so many particles with this size are changing their properties. How the properties are getting changed? Suppose we are well aware with the example of gold. All of we wear the gold as an ornament, and what is the color of gold? Of course, it's a golden color. And in a golden color gold, size of the particle is bulk. But when that golden ornament has been transformed into nano-sized particles, then what will happen? The color of gold will change. In earlier days, means some emperor were not allowed to wear golden color gold, and that time they were started using ornaments of gold, but they were of red color. Means this is not the recent technology. The people 200 years back also, they were known about that material color changes with respect to it's some parameter changing, but they don't know what parameters are exactly getting changed. So we are in today's lecture, we are going to focus on the parameters, which parameters are going to change. So for that purpose, let us consider any metal or material composed of thousands of particles, thousands of atoms, and there is systematic arrangement of atoms, and that systematic arrangement of atoms is called as lattice structure. Means repetitively unit cell is being repeated, and that repeated structure of unit cell plus atom is called as lattice structure. Means every crystalline structure is composed of systematic arrangement of thousands of lattices, and these lattices will give us a crystalline structure. Now exactly what is this crystalline structure? A simple example of crystalline structure we will consider here is a cubic structure. In a cubic structure, here just let us consider this block as a basic lattice of cubic structure. And in this cube, where the atom will lie, this is cube, and we are calling it as a unit cell. Unit cell plus atom will give us lattice, and n number of lattice will compose atom, will compose crystal. So here inside this cubic structure, what will happen? Atom will lie at the corner. So how many corners are there for cube? There are 8 corners. Means number of atoms on the cube: first atom, second atom, third, fourth, fifth, sixth, seventh and eighth. So 8 atoms will lie at the corners of the cube, and hence we are getting 8 atoms at the corner, and the spacing between atom is nothing but this one. We are calling it as A, B or C along the 3 dimensions x, y, z. But for cubic, A equal to B and B equal to C, and hence all the parameters means lattice constant, that interatomic spacing is same in a cubic structure. But when you are going to convert bulk material into nanomaterial, then what will happen? The material atom which were lying at the corners, now we are going to reduce the corners, and atoms which were lying at the corners, they are going to come close to each other, and due to this what happened? The spacing between atoms has been drastically reduced, and this is called as interatomic spacing has been reduced. Now how it affects? It affects on structural properties of the material. how the structural properties of the material are getting changed. Just again I am drawing here simple cubic structure and how the structural properties are getting changed, that we will focus. Suppose the spacing here is A. Now if atomic size has been reduced, then what will happen? The spacing is going to reduce and hence the interatomic spacing, that A has been transformed here, that A dash means immediately you are observing when material has been transformed from bulk size to nano size. Interatomic spacing decreases. And due to decrease in interatomic spacing, what happens? Due to decrease in interatomic spacing, there is change in band gap of the material. As we discussed, or all of we are well aware with the concept of semiconducting material formation or band theory. Within band theory, what we have discussion, that material properties are getting changes. Means with reduced interatomic spacing, electrons will try to exert force on each other, and due to this their energy levels start splitting. Due to splitting of energy level, there is a formation of energy bands or energy regions, and hence we are getting valence band separated from conduction band. Means field energy level lie in valence band, unfilled energy level are separated to conduction band. So due to this valence band and conduction band, there is a band gap. More the less the interatomic spacing, more will be the band gap. Little higher the interatomic spacing, less will be the band gap. Means this band gap is a function of lattice constant, or that is also called as interatomic spacing. And hence structural properties of material are getting changed. Material's band gap changes, material's conductivity changes, material structure also changes, and hence we are observing tremendous changes that I was telling about the golden color gold and red color gold, how the properties are getting changes. Now why that gold has been turned into red color, and the reason behind that is the optical properties of the material. Now what do you mean by optical properties? Optical properties are based on intensity of light coming out from the object. Let I0 be the intensity of the original light which is falling on the object, and I is the intensity of light coming out from the object. Now how this outcoming intensity is dependent? It is dependent on I0 and also exponential of mu into x. Now what is x? X is the length of object, while mu is called as absorption coefficient. And this intensity or this absorption coefficient is inversely proportional to the volume of the particle. More the volume of the particle, less will be the absorption coefficient. Means for bulk material, less absorption coefficient we are observing. For nanomaterial, smaller volume we are observing, and with smaller volume what we may absorb. Means for nanomaterials, volume is small, and if volume is small, then it will give us high absorption coefficient, and this cycle tells us that nanomaterials have good absorption coefficient. Means as if you look towards visible light, all these optical properties are based on visible light absorption. Now visible light starts from violet and ends at red. So what will happen with nanomaterial? Their absorption coefficient increases, means absorption turns towards red side, and we are getting red color gold over here for as a change in optical properties of nanomaterials. So objectives of our today's lecture, as they were crystal structure, unit cell plus atom, uh, constitute a lattice structure. Then this lattice structure, how varies with respect to interatomic spacing, and how variation of band gap with respect to interatomic space, that we discussed here. Now, effect of on structural and optical properties, that discussion also being carried out in this lecture with respect to the band gap variation or lattice constant variation. So this lecture, we are towards the conclusion of this lecture, that material properties are getting changed with respect to interatomic spacing or lattice constant, and hence in nanomaterials we are observing drastic change in materials properties, a drastic change in their behavior, their conduction properties, their thermal properties, and so all these changes are very important for further development of technology. In future, all of we have to deal with the new materials, and the materials will be nanomaterials. So thanks for your cooperation, for listening this lecture. Thank you once again to all of you.